Let me know, Sarath garu, once you are live.
Yes, we are live.
Hello, viewers. Welcome to another episode of Let's Talk Science. So this episode is sponsored by and supported from the members of Science for Society, Indian Humanists, South Asian Humanist Association, and Babu Gognani Humanist and Rationalist Arena. So today we have a very special guest who wants to share his experience and opinions in astronomy, space science with us. Before introducing him, let me welcome Mr. Sarath Teja Somina Garu, a science popularizer and member of Science for Society and BG Group. Welcome, Sarath Garu.
Thank you, Prasad.
And also a regular speaker and the young science enthusiast, Teja Begari, is also joining us from India. Welcome, Teja.
Thank you, sir.
Yeah. Now our special guest for today's episode is Dr. Stephen Clifford. So he's joining us from Houston, Texas. Welcome, Stephen. Dr. Stephen.
Thank you.
Yeah. So he's a senior scientist from Planetary Science Institute, and his areas are areas of expertise are geomorphology and thermal modeling and Earth and Mars and icy satellites, and I think trying to find some sort of water that can help sustain the life, if possible, if we happen to ever colonize Mars or start considering that idea seriously. And a lot of papers. I think I couldn't count the number of citations he has in Google Scholar, sir. It's a really honor for us to have you here. Like, your research for over 40 years has really is really amazing. So welcome to our show. Science for Society and BG Group and Indian Humanists. So we normally do radio shows, specifically are more so in our native language, Telugu. And we regularly conduct science hours and humanist hours in one of the leading Telugu and most popularized Telugu online or web radios. Spanning our live audience will go into hundreds of thousands, and also after that we upload our videos into Indian Humanist channel. So that's how we connect with our audience, and also invite quite regularly special guests and scientists and doctors and the experts in their own field of sciences. So it's very we are very honored to welcome into our show now for this episode. So Sarath Garu, before letting you ask questions, so my first personal and basic general question that most people have, so I'll ask you, sir, when are we going to Mars?
That's a good question.
If whether not going, when are we? I'm not saying colonizing or terraformation of Mars, but at least right. Quite sustainably, like a significant amount of time, humanity will be able to test maybe for a decade or so, and bring people back.
Yes, I think the earliest, the best estimate right now is probably the end of the 2030s. I know that Elon Musk has talked about sending humans to Mars within this decade. And while I think that's an enviable goal, I don't think that it's a realistic one. I think that there's still a lot we need to understand about Mars in terms of the environmental conditions, things like the toxicity of the dust, dust mitigation in terms of how we keep it from contaminating living quarters, and just having basic confidence in the systems that will be required to send humans to Mars and to bring them back safely. the challenges represented by sending humans on a 6 to 8 month voyage to Mars, landing them on Mars, having them stay there and do some science for a while, and then come back to the Earth on another 6 to 8 month journey is a significant problem. And I don't think it's one that realistically we'll be able to address before the 2030s.
Yep. And considering that, we are such an advanced civilization or life forms that we know currently, and we have only one planet for now, and only one place. It's a very small, speck of dust kind of thing in the known universe. So a lot of people are, even Elon Musk says that, it's, we need to have some sort of insurance kind of thing where, we should not put, everything on one small planet, which is very prone for disaster, or another big asteroid strike and gone everything. So so for that, I mean, we're not talking about the extraterrestrial or the interstellar travel again. Like within the solar system itself, I think looking like Mars would be the first candidate for humans to seriously consider moving out and having their presence there. So in that case, I think the first, out of all the essential requirements that humans need to make their presence there, water is the availability of sustainable presence of water could be, I think, in my own personal opinion, the first and foremost requirement, for the sustain, life to sustain there and continue. So where are we in terms of finding sources of water in whatever form that we can tap, to make our travel life safe on Mars?
Well, the most obvious reservoir of water on Mars are the Martian polar caps. And we think there's enough water contained in those polar caps that if you were to melt it and distribute it across the planet, it would form a layer probably 25 meters deep, which is a lot of water. The problem is that water is located at very high latitudes. It's located at the poles, and that makes the temperatures very cold. The earliest human missions that we send to Mars are unlikely to go that high in latitude. They're going to be restricted because of the environmental conditions, the temperature conditions, and conditions, the constraints of sunlight, to lower latitudes near the equator. Maybe the highest latitudes we'll consider are temperate latitudes, maybe up to 40 degrees. And there are no obvious reservoirs of water within that latitude range. However, we've got some indirect evidence for the presence of water at those latitudes. There is a combination of infrared thermal mapping data, radar data, geomorphology data in terms of visual images, some gamma ray spectroscopy data that, when combined, give us some insight as to the presence of ground ice on Mars within this latitude band of plus or minus 40 degrees. And it's possible that ground ice is present in a sufficient abundance that it could be harvested as a source of water. The amount of water that's actually contained in the Martian atmosphere, though, is very, very small. I had mentioned that The inventory of water in the polar regions, when you consider both poles, is equivalent to a uniform layer about 25 meters deep averaged over the planet's surface. In terms of the amount of atmospheric water, we're talking about a layer maybe 10 microns deep averaged over the surface of the planet. So maybe on the order of 1 to 2 cubic kilometers equivalent of water in the entire Martian atmosphere. Now, we think that in the subsurface, in the form of ground ice, and perhaps at much greater depths, in the form of subpermafrost groundwater, there could be the equivalent of hundreds of meters of water averaged over the Martian surface. But the groundwater, anyway, would be very, very hard to access. We think that the nearest, the shallowest expression of groundwater on Mars is probably at depths of kilometers below the surface. But between the surface and that depth, we think that there could be substantial amounts of ground ice. And that looks to be the most viable reservoir of water that we could tap for sustaining, future human explorers.
Thank you very much, Stephen. So, yeah, water is definitely one, but not the only one that is sufficient for any life form to thrive. So, because there are so Earth is perfect for us, but for us to thrive there and live there, because it doesn't have tectonic activity or volcanic activity, and even the required gas mixture in the air to support life. So, but let's talk about water only. So, are there any possibilities of finding a life in the solar system outside Earth?
Well, I think there is a potential for finding life on Mars. I think the greatest likelihood of finding life would have been very, very early in the planet's history, when we've got significant evidence that Mars had temperatures that were above freezing, that liquid water did survive on the planet's surface in the form of lakes, seas, and maybe even a northern ocean that covered as much as a third of the planet's surface. And if life evolved on Mars as quickly as life evolved on the Earth in terms of simple microbial life, then it's possible that as the climate changed on Mars, as the atmosphere became thinner, as temperatures became colder, as the water was lost either to space or by cold trapping into the subsurface, that it's possible that those simple microorganisms were able to adapt to a subterranean existence, and that just like on the Earth, there may be microbes that are present at depths of kilometers below the surface that survive to the present day as long as water is present. On Earth, there are a number of microorganisms that are quite content on surviving on only the presence of water and rock. And the minerals that are present in that rock, in combination with the presence of liquid water, provides the kind of environment that these microbes can survive in. So I think that Mars very likely evolved life back early in the planet's history. The question of whether that life survives to the present day, though, I think is contingent on whether or not groundwater is present at depth, or whether all of the liquid water that was once present on the planet has now been lost. In terms of elsewhere in the solar system, I think there are actually a number of other places that are potential habitats for life. Certainly, the Galilean satellites, Europa, Ganymede, Callisto, all three of those are thought to have mantle oceans beneath a frozen outer crust that might be on the order of 10 or more kilometers thick. But we think that beneath that frozen outer crust, there is a liquid water ocean that extends down, 100 kilometers or more on all three satellites. And there's evidence of similar conditions elsewhere in the solar system in terms of Saturn, Uranus, and Neptune. Even Pluto is thought at great depth to still possess a liquid water ocean down at depths of maybe 100 kilometers or more below the surface. So the potential certainly exists in all of these environments for life to have evolved. And we have no idea what the limits of the evolution of that life might be. It might be very simple organisms, microbial organisms, but it's also possible that more advanced life forms developed in the subsurface. And that remains an area for future investigations. I think that missions, particularly missions to Europa, have a great deal of promise for discovering life in the solar system. One of the techniques that's been discussed is sending a submersible that would melt through the frozen outer crust of Europa and then explore the subsurface like a submarine. And I think that could result in some very, very surprising discoveries.
Yeah, we will all be waiting for any sort of news, that's related to life outside Earth, at least at the moment. If not from projects like SETI, where we are looking for much advanced, intelligence presence, and at the same time, like our, I think current missions to Mars, like the Perseverance or the Ingenuity helicopter, like they are all trying to find signs of at least past life, if not present life, and some form of oceanic activity. So it will be, that evidence will help us change or have opinions about where to find life, or how life can, if it can, prevail and sustain and grow, in different environments. So that's very good insights from you, sir. So Sarath Garu, so you can take over from here. Ask questions if you have.
Hi, Steve. So as you explained, the possibility of life having existed on Mars, or even continuing to exist now, any form of life, whether it's microbial or anything that is even more advanced than a bacterium on other planets. All this seems to be hinging on the possibility of water existing in liquid form and being existing in a particular temperature. It's warm, like that on Earth. So would you think water itself is the smoking gun to think that life is quite possible to have existed in the past or here? Because when we understand life is water is crucial to biochemistry, the biochemistry of our type of life. But would you think other things would I mean, of course, other things are necessary, but other conditions are also fulfilling apart from the warmth of water and water existing there? What do you think? Is that the smoking gun, or are there other things more important than that?
Well, I think in terms of life as we know it, I think liquid water is a necessary component of the environment. However, there is always the possibility of life as we do not know it, where there are other liquids that act as the organic or the equivalent of an organic solvent.
Like methane on Titan, would you say?
Methane, ammonia. I mean, there are a number of possible liquids that could provide the necessary environment for a different kind of biochemistry to evolve. And I think one of the great goals of our investigations of Titan is going to be whether or not there is an alternate biochemistry that may have evolved on Titan. Certainly, Titan has many characteristics that are similar to the Earth. The primary difference being that there is a huge difference in temperature, and where liquid water is the substance that has eroded our landscape, and silicates have been the primary component of the Earth's crust. On Titan, you've got methane and you've got frozen water ice. And it'll be interesting to see how the geomorphic similarities that we see that seem to suggest that Titan has experienced erosion of its surface, the equivalent of rainfall, but methane rainfall. Very, very similar geomorphologies as to what we see on the Earth and Mars, for that matter, to see whether or not life was able to evolve in that kind of environment. I don't know when the opportunity to send something like a submarine to explore the European oceans is going to occur. But I know that there is a lot of work that's being done right now to create that possibility.
And all this research, right now we classify it as planetary science, if my understanding is right. And this is something that's that's a field that has originated, that has kind of pretty much separated from astronomy, something like a few decades ago. So when would you say planetary science as a separate area has started? I mean, you did your PhD in astronomy and astronomy, yes. Astrophysics. That was like one set of like fields that people would gain expertise in, and later on they would move on to planetary science. So when would you say, if you look at the history of planetary science, when would you say it's separated from these other areas?
Personally, I think that planetary science became a distinct discipline, probably with the early investigations of the moon, when we sent spacecraft to the moon. I think prior to that time, prior to the early 1960s, although there was planetary work that was being done, I mean, Galileo observed the moons of Jupiter and looked at the planets through his telescope, as did many, many others, Tycho Brahe, and a number of the early astronomers. I think it was viewed at that time as being equivalent to all other aspects of astronomy, eclipses and lunar and solar eclipses, what was known about other stars at the time. I mean, even as recently as 100 years ago, there really wasn't an appreciation for how vast the universe is, and the fact that many of the things that have been categorized as nebula were actually other galaxies. So, so we had sketches of canals on Mars, we had sketches of the craters on the moon, and eventually photographs. But really, I think planetary science came into its own with the sending of spacecraft to the moon, Mars, Venus, and as time has gone on, to the other planets in the solar system.
And I think it's interesting that you said that that you mentioned that planetary science has actually originated into a field of its own, largely because of the space missions. When we were exploring what's beyond the Earth, and we were actually exploring them closely from those objects, rather than looking from here, like Galileo did, or Vestra Slipher did, for example. I mean, when just before the nebulae were classified into galaxies, I think his work was crucial. So. So what would you say to this argument that how useful is exploring outside, spending money on on space missions and studying planets outside Earth, and then because this activity typically comes along with the suggestion or the futuristic idea that humans may at some point of time go somewhere to settle down. So would you say that? And there is also the argument that's being made that there is also this thing that is pointed out frequently, that we have to preserve Earth a lot and we have to study the Earth a lot. So would you think these two are orthogonal, in the sense that would you think sending things into space and studying the planets, of course, it created very interesting branches of study like planetary science, in which you are an expert in. But would you think that is also helpful to alleviate the pressing problems on Earth? Are these two not orthogonal really, and are these two aligned? What would you say?
I think they're very much aligned. The only way that we have of understanding the complexity of the Earth's climate, of the uniqueness of the conditions which exist on the Earth, is really by looking at other planets. We understand the greenhouse effect far better because of our explorations of Venus, where the greenhouse effect is, we've got a runaway greenhouse that has resulted in, the closest approximation to hell that we can find. We see evidence that early Mars, even with a solar output that was perhaps a quarter to a third less than what the sun puts out today, still had temperatures that allowed liquid water to survive on its surface. That too tells us something about the power of the greenhouse effect. So there is a lot that we've learned just in terms of the radiative properties, the thermal properties, the climatic effects of changes in atmospheric composition by studying the atmospheres of the other planets. There is also an incredible record of climate change that's preserved in the Martian polar layer deposits. We see layering that we can associate with the kinds of astronomically induced variations in surface temperature on Mars. Mars currently has an axial inclination that's about the same as the Earth, but we've got a great deal of evidence that suggests that the axial inclination of Mars varies from as little as 0 degrees. So the spin axis is perpendicular to the orbital plane, to as much as 60 degrees. And we see a record of those kind of variations in the layering that's observed in both the North and South polar layered terrains. So we're very anxious to go to those terrains and analyze that record, which can also tell us something about how those astronomical variations have affected not only the climate of Mars, but might potentially affect the climate of the Earth. And that might help us understand the record of climate change preserved in our own polar regions and in places like Greenland, and in the sediments that we find, the sedimentary structures that we find in the Earth's oceans. So there is a great deal, I think, that can be learned about the stability and the evolution of the Earth's own climate over geologic time and what implications that has for the impact of human-caused climate change in the future. As for the importance of planetary science, planetary exploration, whether robotic or human, when viewed against some of the needs that the Earth obviously has in terms of our, ensuring that we minimize the impact of human climate change, that we provide the kind of resources that are needed to feed the world's hungry, those kind of issues. So I think that the amount of money that we spend on planetary science, solar system exploration is a very, very small part of what is spent globally on things like military or cosmetics or high-end automobiles. And I think when you put it in that kind of context, I think that the benefits that we get from the exploration of space are a much better return on our investment than many of the other things that we spend money on.
Yeah, I think it's certainly true that a lot of things that we did not even think of, that a lot of technologies that were created simply because we were trying to solve problems, either sending things to space or to study things, these heavenly bodies, the Mars or anything. I think everyone right now knows about infrared thermometers, IR thermometers, and they were largely designed to measure temperatures in space, I believe. I mean, that's a technology that was created to solve a problem in outer space. And I think it's also interesting that you point out that that climate change, what we understand about climate change, is largely because of the data, and that the knowledge what we have on climate change on Earth, and how space missions have contributed to it directly. And this leads me to point out this contrast that everyone is excited about space missions. When we do something adventurous, or when we do something that is interesting or outright brilliant, like sending people to moon, for example, that was a great statement of what humanity can achieve, can even think and do. And that has spurred a lot of cultural movements, like even environmentalism, for example, and the need to preserve Earth. And it also inspired a generation of scientists, a generation of kids at that point of time, school-going children to do science, to go into scientific research and things like that. So at the same time, we applaud about what we do on space, but these implications of what we learn about things on Earth based on what we study in space, like climate change, is something that has become contentious in today's time. And especially, in many countries, including United States, there is this spectrum of belief that is very much supported in the political ecosystem, from outright denying the climate change and to saying something like human activity, anthropogenic. It's not anthropogenic climate change. I mean, it's not because of human activity. It's something else. And what would you say when you look at these two, the same politicians who vote for budget, for planetary missions to do things, adventurous things in space, what people have done across Atlantic, like I think 300 years, 400 years ago, what we are trying to do in space, at the same time denying the implications here. What is your view on this kind of contrast?
It's a very, very troubling aspect of today's politics, particularly in the US. There are many people who should know better who deny the science. The connection between the increase in global temperatures over the past few hundred to 2,000 years tracks perfectly with the increase in CO2 that has resulted from deforestation, from the burning of fossil fuels, and tracks the amount of warming that has occurred from the increase in CO2 that we've measured by looking at the gases trapped in ice cores and other things. The temperature increase tracks right on the nose. So the scientific evidence for the human aspects of global warming, the human relationship, the connection there, is very, very clear. And I think one of the problems is the lack of understanding of science, of the scientific method in the general population. Certainly that's true in the US. I don't think we have been as good as we need to be as scientists, as educators, in communicating the scientific process, the scientific method, and the importance of applying that method to understanding things like climate change. And you have political opportunism. You have politicians who see an opportunity to appeal to those who least understand science and have sort of an emotional objection to what they hear in terms of the connection between human development, technological development, industrial development, and global warming, and have that feeling, that expression, those political beliefs, those ideological beliefs, because they don't really understand science. But there are politicians who know better, who do understand the science, but see that by tapping that group that does not understand science, it promotes their own political progress, their ability to seek higher office. And I think that that's in the US a real problem. And it's a problem that I believe is found just about everywhere else in the world as well.
And do you think there is also this, do you really think that there's an argument that is frequently made that people, there is an increase in distrust of scientific experts among general public? If we look at the way how things have unfolded during COVID pandemic, for example, COVID was probably the biggest challenge that everyone had faced on the planet. I think in the recent times, I think in the last 50, 60 years, I think apart from the economic collapses, COVID was the major thing that risk that everyone has faced on the planet. And yet, even though, I mean, if we look at the overall thing, the reason so many people did not die due to COVID, if we compare with any previous global pandemics, like the one with swine flu before, or even the Spanish flu before, the main reason why fewer people, a lot of fewer people have died or even contracted disease, and the reason the pandemic was finished in like at least 2 to 3 years, it has milder, it is now mild at least to this level, is largely because of scientists, and it's largely because of the technology, the computing technology, all the collaboration that people were able to do. Even then, we still see people at large with vaccine hesitancy, hesitancy to take vaccines, and also even to follow basic guidelines like wearing masks or washing hands, and falling prey to non-scientific things and pseudoscientific things. And even in the United States, Dr. Fauci has faced a lot of flack across, I think, the board. What do you think of this? I mean, in 21st century, when people are using technology, and even though scientific experts, there is consensus and they say, this is what we have to do, even then people don't agree to it. May not be simply because of politics, but do you think there is also larger distrust of scientific community, scientific experts among general public?
Yeah, I think that there is a distrust of experts in general, whether in science or in other areas. And I think, again, it's in large part because of the failures of our educational system. in the US, we have a history of categorizing children at a very young age in terms of those that show academic promise and those that perhaps are headed to more to a lower level of standard of job opportunities of education, and I think that's wrong. I think that we should not be so focused on trying to emphasize to focus on the best and brightest that we see at a very young age, because there are many students who are late bloomers. I was a late bloomer back when I was in 6th grade. They had broken down the students in 6th grade into 6 different academic levels. And the top few were considered college material, where they were considered to be the ones that were going to go into professional careers. The ones near the bottom didn't get the best teachers and were sort of given up on. And I think that that's a terrible shame. For me personally, the thing that made the difference, that got me excited about education, was science. I had a very, very energetic, enthusiastic, very knowledgeable science teacher when I was in 6th grade. And that really turned me on to science. That and an interest in science fiction, which I also had at a very early age. And that stimulated the imagination and got me so that I went out and bought my first telescope and looked up at the stars at night. So those things captured my imagination and inspired me to go on in science. But there were many kids that I knew back at that time who were just as bright as I was, but because they didn't get that spark, they didn't get that inspiration from a teacher, from what they read or what have you, they did not go on to succeed in the same way that the kids that were thought to be smarter eventually did in terms of the opportunities that they had. And I've always thought that was a shame, that we really need to spend more time trying to find that thing that ignites the interest and enthusiasm of students at a young age, so that they are able to fulfill their promise, that they're able to take advantage of opportunities that come their way.
That's I think that's a very I think insightful thing to say, Steve. And on a lighter side, so you said you enjoyed science fiction.
Yes.
So you're a fan of the golden age science fiction, Asimov, Heinlein. Is that, or do you also like contemporary science fiction, which is more dystopic?
Yes, actually, my first encounter with science fiction came about as a result of a book that my cousin gave me, and it was the name of the book was Tom Swift and the Visitor from the Planet X, and it was a book series that it was aimed at very young people, and it was kind of corny, but it provided the incentive to go and find other science fiction books that I read, and Robert Heinlein and Isaac Asimov and Arthur C. Clarke, and you know, there were a host of them that wrote books that just really I mean, my earliest interests in Mars certainly came about from the writings of Arthur C. Clarke and Robert Heinlein. They created this world in my mind of domed cities and canals, and it was very, very exciting in terms of what I was looking forward to in our exploration of Mars, even when I was still, a very young child. I can remember very, very clearly when Mariner 4 flew by Mars in 1964-65, and took the first pictures, close-up pictures of the surface. And when I saw those pictures, and the most identifiable feature in those pictures were craters, I got very depressed because the only other object that I knew of at the time that had craters was the moon, and the moon was lifeless. And suddenly this idea of canals and domed cities just evaporated. And I think the next few years were very disheartening. Mariner 4 was.
So you realize there was no Santa Claus, Tooth Fairy, and Martians. So all the three of them.
yeah. And I'm afraid Mariner 6 and 7, they flew by essentially the same portion of the Martian surface that Mariner 4 had flown by, which was the southern hemisphere, which is the oldest terrain on Mars, and which is the most heavily cratered terrain on Mars. So up through 1969, our understanding of the potential for life on Mars, our understanding of how Mars had evolved as a planet, turned out to be very distorted. And it wasn't until Mariner 9 went into orbit in 1971 that we began to see how different the rest of the planet was. The fact that there were these huge volcanoes located on the Tharsis Bulge, this bulge on the equatorial region of Mars, where you have the tallest volcano, the largest volcano in the solar system, Olympus Mons, where you had not only carbon dioxide in the Martian polar regions, but you also had water ice, that we saw the evidence of fluvial erosion on the surface, ranging from everything from very fine dendritic-like valley networks, which suggested that the Martian surface had been exposed to rainfall very early in its history, to huge dry riverbeds that had inferred discharges that were 1,000 times or more greater than the largest river systems on the Earth, like the Amazon. We saw evidence of cold climate features like pingos and patterned ground that we find in the Arctic environments on the Earth, and we also found these on Mars. So Mars turned out to be a much, much more complicated planet than our early flyby missions, Mariner 4, Mariner 6 and 7, had suggested. So we owe a lot to those early robotic missions to Mars, particularly the ones that went into orbit, like Mariner 9 and the Viking missions.
So when you look at all the sci-fi that's centered around Mars, so I mean, we started from the Martians, and there was a film Martian, that recently came out. What do you think? I mean, what do you think of the film? I mean, that film, a lot of people have a lot of opinions on that. I think we respect all those opinions. What do you think of that film? I mean, do you think? I mean, I think one strange thing that I noticed was the reliance on potatoes in that film.
Yes.
Would you think if really people went to Mars, they would hinge their lives on potatoes, or would we? I mean, we did at some point of time, like 300 years ago, when potatoes increased, the number of people who would survive. But would you think really potatoes have a future in humanity?
Well, yeah, I think potatoes will be part of the diet when we get to Mars. I hope they never become the dominant source of food for future human inhabitants of Mars. But I think in the particular aspect in which potatoes were featured in the Martians, in the Martian, was simply because it was something easy to grow that he still had in the habitat. And
is it safe to grow it with human waste? I think there are some bacteria that would come into the plants and that would be deadly.
It could be. I'm not an expert on that aspect. I think The Martian was a great story. It was entertaining, but there were a number of scientific aspects to it, not the least of which was his getting sort of blown away and hit by a piece of antenna in a Martian dust storm. And with an atmospheric pressure that's less than 1% of the atmospheric pressure of the Earth at sea level, there's no way that could have happened.
He could have blown through the storm and everything would have cleared up.
Yeah, but it was an entertaining film. I get entertained and excited and inspired as a child by Star Trek. And there are many aspects of Star Trek that are not supported by our understanding of science. Nonetheless, it is a show which inspired so many young adults at the time, so many adults at the time, that I think science fiction plays a very, very important role in creating the inspiration that results in people going into science, into engineering, into medicine. And I think it's important to have that as part of our culture, to have those things that, maybe they're not 100% based on science and facts and whatnot, but that is what I think is sometimes needed to stimulate the imagination and get us thinking beyond what we're just familiar with on a day-to-day basis.
Yep.
I think that's a wonderful thing to say, Steve. So, Teja, do you have any questions for Dr. Clifford you would like to ask?
Yeah, there are a few I got as well, so which I would like to add upon. So what other types of robotic missions, aside from exploratory rovers and samples written, do you think should be sent to Mars, and why do you think the other types of missions are important rather than these?
Well, in many respects, I think that our exploration of Mars has not proceeded in the most logical way. I think if, for example, we were to send a probe to a nearby star system to look at the planets that were present around that nearby star, there's a certain order of investigation that you would naturally expect to occur. And I think the initial thing would be to put in orbit spacecraft that could image the surface of the planet using infrared, using visual, to do sounding investigations with orbital radar. I think the next logical step would be to send network missions, to send a number of landers that would operate on the planet's surface at the same time, to do studies of the planet's meteorology, to do geophysical investigations of the subsurface, to do imaging of the local landscape. And it would be a way of inexpensively investigating a number of different local sites across the planet. Then I think that the next kind of investigation that you'd send, the next type, would be the rovers to whether or not they're wheeled rovers or there are things like Perseverance, things like helicopters or aircraft or balloons that could do aerial studies at a much lower altitude, so that they could do very detailed investigations at the surface, perhaps land at a particularly interesting location that might be inaccessible from a rover. To do very basic kinds of analytical investigations at the surface. And that's the kind of approach that I think if we had in our exploration of Mars would have given us a much better understanding of the planet at this point in time than what we have now. Unfortunately, I think that much of the selection of what the next mission is going to be on Mars has been sort of tweaked by what is going to employ the most people. And that tends to be very, very expensive, very large rovers at the present time. And as a result, the kind of network missions, the kind of simple landers that could do things like study the atmosphere and its motions, the local environmental conditions at perhaps 10 or 12 or more different places on the planet's surface. Those haven't been done. And also, I think the geophysical investigations are very important. This InSight mission that we sent that has a seismometer, they've been able to do incredible things with the information, with the data that they've gotten back from that instrument, but would know a lot more in a much greater detail if we sent a network mission or we had multiple seismometers on the surface of Mars. There are also electromagnetic investigations where you send very low frequency electromagnetic waves into the subsurface that can tell us things about the conductivity of the subsurface as a function of depth and the geography of Mars. And that can tell you things like whether or not groundwater is present at depth, whether or not there are brines that occur on a diurnal or seasonal basis in the subsurface. So there are a lot of things that I think could be done by far simpler and less expensive missions than the rover missions that we've sent to Mars. I think the rover missions have been extremely successful. But again, we're looking at just a very small area with those rovers. And I think there's still a lot that we could find out about the rest of the planet through sending multiple less sophisticated spacecraft landers across the planet's surface.
Yeah, and also another question I would like to ask is, we hear quite a lot about diamonds raining on Neptune. Do you think that is true?
I'm sorry, I didn't quite catch that.
Do diamonds rain on Neptune?
I have no idea. I read that with quite a lot of interest too. The calculations seem to suggest that yes, diamond rain could occur on Neptune, but that is certainly something that I never would have thought of. So it takes people who are sort of looking at the special conditions that exist at Uranus and Neptune as to whether or not processes like that can occur. I think we're also beginning to understand a lot about the potential for the variety of different planetary environments that might exist by studying the exoplanets. We've seen planets in places that we never expected, with Jupiter-sized planets that are at equivalent distances of Mercury to the sun. These hot Jupiters were just completely unexpected. We've found other planets that are rocky planets but are so close to their parent star that they've got an atmosphere that's composed of metals. There is just such a wide range of possibilities now in terms of the kinds of planets that we find elsewhere in our galaxy, that I think it's providing a context for understanding our own solar system that we would not have had if we hadn't conducted investigations like the TESS orbital investigation that looked at the prevalence of planets around other stars.
Yeah, and one more question is, and it's basically like in India, we have the ISRO, and scientists at the ISRO basically do prayers and the so-called muhurtams before they actually launch a mission. That was also done for Chandrayaan-2. It was still a little bit of failure kind of thing. And what do you think about scientists with the huge visibility when they do all this, something like against the science or something like that? What do you think when leaders of scientific institutions with huge visibility in public do this kind of thing?
Hard to say. I mean, I think that there is a natural competition for funds within many organizations. And please correct me if I've misunderstood what you're asking, but there is politics everywhere in science as well as in government. And we have had in the US, for example, those who have argued that we should spend our scientific research, our investment in science and space exploration solely on robotic investigations, that humans really have no place in the future exploration of the solar system. And I think that is a very mistaken attitude, because I think it is the human element that provides much of the motivation for wanting to explore.
So Steve, just to set the context, just to give more context to the question that Teja asked.
Sure.
So these are incidents where these are recurring incidents where the head of the Indian Space Research Organization, the head and department heads, they visit temples to seek blessings before rocket launches, before important missions. And
Okay.
there was this incident before Chandrayaan-2, where the ISRO, the Indian Space Research Organization head, he was an aerospace engineer. He's an aerospace engineer. He has a PhD in that aerospace engineering. Dr. K. Shivan. He went and sought blessings of the head of a religious institution. It's called a Udupi Mutt. And then there were also in media and in newspapers, there would also all these kinds of reports that that ISRO scientists themselves seek auspicious times from these holy seers to fix the time for rocket launch of all things, as if the planets decide not just human affairs. I mean, for goodness sake, even the future of a rocket that's going to be launched. So, and you mentioned something. You actually talked a great deal about the need for scientific literacy and scientific education in society, and how it's important for public to understand that. So when you see public officials of scientific standing having with great public influence do these kind of things, what kind of thing? What do you think it's good, even if they have personal beliefs? Do you think as heads of institution they have some standards of behavior they have to set towards to, especially in a country like India where large section is illiterate and scientifically illiterate?
Yeah, I think that there is a distinct difference between science and religion. And scientists may have religious beliefs, but decisions in terms of launch dates, in terms of what kinds of investigations you send, that sort of thing, have to be based on hard science. Religion has a place in the personal lives of individuals, but it doesn't have a place in terms of deciding scientific criteria for things like investigations, launches, and what have you. You know, there are people in planetary science in the U.S. Some of them are atheists or agnostics, but I also know that there are scientists, very good scientists, who have much more fundamentalist kind of beliefs. You know, have a very deep religious orientation of their life, but they know how to distinguish and how to separate their religious beliefs from their scientific work and the needs that scientific research has in terms of looking at the hard evidence for whether it is the evolution of Earth or whether it is the evolution of life, that while they may invest a great deal in the biblical stories about how life evolved, that there was an Adam and Eve and that sort of thing, they're also capable of looking at the geologic record, looking at the evidence for the evolution of life that's preserved in rocks, that paleontology has told us about the dinosaurs and the evolution of mammals and that sort of thing. And so I think it is in fact possible to separate out personal religious beliefs with science. And I think it's a necessity if science is to advance.
And on a related note, like I would like to bring up something that you may not like much from the place where we are coming from. So the position of Mars at the time of birth of a particular of people, brings bad luck, or they'll get hard time finding their mates. So superstitions like that. So there are a lot of them associated, especially with Mars. So yeah, so general public. So there is a lot of superstition, and also those who promote pseudoscience and misinformation and disinformation in social media for their own personal benefits. They use these kind of examples where famous or noted people, especially related to science, like when they do some things like this in public life, so they'll take this as an example and quote them, saying that it's what we know now is not everything, and there is some magic behind that is still waiting to be explored, some things like that. So yeah,
say for
so
instance, I mean, you are so passionate about Mars. I mean, a lot of your research is on Mars, and in India the most popular thing people know about Mars, as if it's a matter of fact, is that it stops your marriage. And we just came to know, Neptune might help you in getting married with diamonds and all. But Mars stopping you from getting married is something that is so prevalent. And people, I mean, their lives get upside down because of this. arranged marriage is still a huge thing in India, and most of the marriages are arranged marriages. And if someone has Mars in a particular place in their horoscope, which is not even a piece of paper worth looking into, I mean, it really hampers. I mean, it really makes their life upside down. What do you think? I mean, on intuitive level and an intellectual level about this kind of thing. I mean, you probably are, I think, one of the people who know on this planet who know about Mars the most. So, I mean, when people believe in this kind of things, like astrology, horoscopes, and when superstitions about Mars, what do you think? And the people, the astrologers, is a big business in India, and they give these kind of examples where you look at this ISRO's head, the top science guy. This guy went to to pray for the blessings of planets to launch his rocket. So this is how it is. What kind of view do you have on that?
There is absolutely no evidence that there is any connection between the motions of the planets, whatever planet you choose, and the future of individuals here on the Earth. I think about the only connection that there has ever been, that there might be some relationship between the way an organism functions on the Earth and what's going on in the sky, is the similarity in menstrual periods with the duration of 28 days and the lunar cycle. But in terms of any connection between Mars and people's conduct, whether it's marriage or any other aspect of their life, there's absolutely no evidence that there's any connection at all. In terms of how someone in a high position in a space agency may consult with spiritual advisors as to an opportune launch date, it would be unfortunate if that was the true motivation, but it might be understandable in a society where there was faith in astrology, that it might be done for political reasons, that it might be done to address the belief in the broader community that there is a relationship, even though that individual may be well enough educated to know that there is no relationship there. Certainly that kind of thing has happened in the US, where people who knew enough about science to know what they should be saying, but because the appreciation in the general voter population was something different, tried to appeal to that audience to make their work more acceptable.
And for example, I mean, this is even beyond horoscopes in Indian society. For example, today is a lunar eclipse, right? So, and it's a beautiful sight, and especially people who like to photograph moon and celestial objects, they are very much delighted to try to capture moon when there is low light, when it's in eclipse. You can clearly get the craters right and all that, and incidentally, and a very interesting piece of history in ancient Indian astronomy is that Aryabhatta in 4th century, he wrote a book, and then he wrote a work. In his work, he reasoned that the shadow of the Earth, which is pretty much what the lunar eclipse is all about, is round in shape, is circular in shape. So the Earth must be spherical in shape. He reasoned that out. And that it did it in 1600 years ago about the shape of the Earth. So, and even today, people are afraid of eclipses in Indian society by and large, and it's all mixed with the culture, with astrology, with and the popular notion is that the eclipse is not because of shadow or light and shadow, but it's because some celestial snakes they eat, they gulp, they swallow Earth, sun, or moon. and then they release it. So it's called, eclipse has. So that's the terminology that goes in. And it so happens that on eclipses, especially, pregnant women, they are forced not to eat. I mean, it's the popular superstition is that food gets spoiled because there is no planet, because there is no moon, so that there is no power of the moon coming in and all these sort of things. So you're not supposed to eat anything, and especially pregnant women are forced not to eat because it apparently harms their babies. That's the popular notion, and it's very difficult to fight these kind of things. And these kind of things, when they happen on a broad scale at levels of authority, they just reinforce this kind of culture. How would you say we tackle it? I mean, it's clear to whoever examines the evidence, like a scientist does, or in the method of science, it's very clear that these things don't have a relation to any each other at all, and these are just superstitious nonsense. But what do you think is the approach to convince the public, I mean, who can't appreciate evidence in this fashion, just to make them realize that there is no bearing of these things in their life? What's your suggestion in that as a scientist?
Well, I think the ultimate solution is to begin scientific education at a very, very early age, to look at what's to teach young people the scientific method, to do it with simple things. Might be initially in terms of physics and just looking at a ball rolling down an inclined plane and what kind of observations you need to make in order to understand that motion. It might be looking at microorganisms in pond water or river water, and understanding what's necessary in terms of how life may have evolved from those simple organisms, or what the characteristics of those simple organisms are versus more complicated organisms. Just begin to introduce them to the aspects of the scientific method, so that when they become adults, they do so in a more in a way where they understand the difference between superstition and what can be concluded based on observation and facts. And so in my own past, I really don't remember much in the way of any kind of introduction to science until I was in my 5th or 6th grade. And I think that's too late. I think that there are ways of introducing science at a much earlier age. And that may be limited by the resources in the local community. There are many parts in the United States where education is funded on the basis of the financial resources of that local community. And we have some great disparities in terms of wealth, of the money that's available for education in the US. Those that are in more affluent areas are able to get a really top-notch education. But unfortunately, in the US, we still have many areas, many rural areas, and even in some urban areas, where there is not the financial resources to provide a really good education. And I think that in each country, there is a need to find a way to get beyond the idea of education being simply a local responsibility. I really think it's a national and global responsibility, and we need to work as a nation and work as a globe through organizations like the United Nations to make sure that we have the resources and capabilities and opportunities available to people everywhere, wherever they're located, whether in Africa, in India, in Asia, or in many environments in the U.S.
It's interesting that you mentioned that, it should be a collective work, and we need to have global efforts in doing this, because the level of pervasiveness of this particular problem, it's not just, I mean, it's even though it's high in Indian society, there are people who are actually doing it on global scale. For example, there is this person called Jaggi Vasudev. He calls himself Sadguru. That's a title that he conferred upon himself. It means wise guru, but I'll tell you what his wisdom is all about. So especially he actually, there is a YouTube video of him. He has huge popularity in India. He speaks in English, and then he actually goes and speaks in forums like World Economic Forum and also some of United Nations forums. And he says, I mean, there are YouTube videos, where he says that how women should not, menstruating women, should not do certain things, how their biology is different when they're menstruating, how different energies come into them and all sorts of things. And more famously, he actually did a farcical performance, on a day of an eclipse. So he actually showed it on, I think it was on a full moon day, or it was on a new moon day. I think he did this. He took some food. He did some pendulum dosing. This farce he did. And he said, look at how the pendulum is so swinging so fast near food. It's because of the moon's power. That's why you should not eat this food during eclipse. So, and these, I mean, I just gave an example of this person. And he was featured on Trevor Noah's show, I think like a few months back. And he was doing a farcical rally to save soil by driving, vehicles that don't even give you like 10 kilometers per liter mileage. So that's the kind of thing he does. And people like this, they get platforms in World Economic Forums as some sorts of guides, experts. I don't know in what, but they get invited to these things. And he also addressed United Nations some platform, I think a few years ago. Do you think the media should look at these kind of things differently? I mean, some person who might be coming from a country like India or any other developing country who might be representing the culture of that country, do you think the media, I mean, he was featured on this Trevor Noah show. It's quite a popular show. And Trevor Noah is, I think, a lot of times, Trevor Noah calls out, politicians and other people in the United States who think in superstitious way or pseudoscientific ways and anti-scientific ways. And this person he made a living out of, talking things like that. So do you think there is a gap in the way how media, scrutinizes their guests, simply because they represent some culture, they call themselves representative of a culture of a developing country, because there is this whole, because they made their living out of this kind of propagating this kind of things. What do you think? Do you think media in the West has this problem?
Well, yes, I definitely think media has the problem. In the U.S., we have what I would consider responsible media, media like the New York Times, the Washington Post, National Public Radio. There are a variety of outlets that are very rigorous in terms of what they report. But we also have less sophisticated media that sees an opportunity to get an additional viewership, an additional circulation by promoting things that factually they know are incorrect. But because there is a large fraction of the population, or at least a large fraction of the audience that they want to appeal to, who do have those beliefs, that they promote stories on that sort of thing. For example, at Loch Ness, I'm sure the local Visitors Bureau likes to promote the fact that the Loch Ness Monster is real and the stories about the Loch Ness Monster, even though the scientific community, I think, is fairly well established that we don't have any prehistoric sea serpents going around in the Loch Ness. That's one example, but there are many, many others, and there are charlatans, individuals who claim a special understanding of nature, of God, of what have you, that they may be true believers themselves, or they may just be con artists. But I think the only way to address those kind of influences is again through education. And it's a problem in that education is not instantaneous. We can't set up an educational system and the next day everybody is going to be well educated. It's something that unfortunately takes a while, takes in many cases generations. And the only way it's ever going to be accomplished is if we start doing what's needed in order to provide those educational opportunities for people starting now. And hopefully within the next 10, 20, 30 years, we'll have a population, both a national population and a global population that will be more informed and more educated and more able to distinguish between what is fact-based and what is a con, what is something that is appealing to our emotions and our ignorance rather than to our logic and understanding.
And you may find it amusing that in India here, all this fake information, they make use of NASA's authority. They say NASA has said this, NASA has said that. One example is about the sound from sun. So I mean, we know that so all these density fluctuations on sun's corona, I think they are just translated into sound like ECG, nothing more than that. And you hear it. I mean, it's not anything. I mean, you just hear it. Maybe our ears are good at finding density fluctuations better than our eyes. When we look at graphs, that may be the only purpose. But it became a sort of thing of its own. And I see a message in my WhatsApp every 5 days saying that NASA has confirmed that the son of sound is Om. This Om is a holy sound, in the Hindu religion, or Sanatana Dharma as they're calling it these days. So does sun really release these these Vedic chants, or of the subcontinent at 23.5 latitude? I mean,
yeah, I mean,
and NASA give a sign of approval on this? Really?
No, there have been some recent stories which have attempted to say that black holes have sounds associated with them. And again, it's just a translation of measurements of the intensity of certain wavelengths of radiation from the dust and gas spiraling into a black hole, and trying to associate sounds with the intensity of that radiation. And it has no relationship to an actual sound that's being emitted by the sun or a black hole. Sound doesn't propagate in space. There may be seismic waves, seismic disturbances that propagate in the sun that tell us something about what's going on in the interior of the sun. There may be, certain frequencies that are emitted by the gases and dust that's being accreted by a black hole. But those are far different things than anything that has any spiritual or astrological significance.
I think it's getting very late for you. So definitely the conversation is really going very interesting, and we will catch you up with some other time because it's I think probably midnight for you and Sarath as well. Um, so I'm from Sydney. It is okay for me, and Teja okay for Teja too. But yeah, it's probably very late for you too. So uh, I'll ask one last factual question before closing. That is with the kind of limited budgets that scientific missions get each year. Um, what is your opinion? The next logical step needs to be? Should we focus on sending people to Mars, or just try to send some rovers to Mars to learn more things, than going back to the moon, like spending tens of billions of dollars to do what we have already done 50, 60 years back? uh, because I mean, we have had enough missions to know enough of moon. So that's one last question, sir.
Yeah, that's a question that has been intensely debated in the United States over the past 20 or 30 years. Whether we should return to the moon or skip the moon because we've been there, done that, and go on to Mars. And I think that there are some very pragmatic aspects to that decision in terms of using the moon as a way of proofing our ability to land and explore on a planetary surface, to set up a human settlement, when the distance involved is such that the possibility of rescuing, if something goes wrong, is much more realistic when you've got a travel time of 3 or 4 days from the Earth to the moon, than to skip the moon and undertake voyages of 6 to 8 months to go to Mars, where the opportunity to rescue, to respond to an emergency that happens in flight or happens when the astronauts reach the surface, is much longer. And I think it's good to test our ability to explore a planetary surface, to set up a habitat that can support astronauts for a considerable length of time, for months to years, and to test that hardware in the near Earth environment, in the lunar environment. But I also think that there are some science questions that we still need to address. Look at the amount of water that is trapped in the lunar poles, to understand more about the internal structure of the moon, which may have relevance in terms of the evolution of the moon and also the evolution of the Earth. There's a lot in terms of understanding how the moon formed, the similarities between the composition of the moon and the Earth's mantle, the way in which the moon was born, the possibility and very much the likelihood that the moon formed out of the debris from a collision between another protoplanet and the Earth, 4.6 billion years ago. So I think there are still scientific questions, and I think there are practical aspects in terms of providing the assurance that we have the technology and the knowledge to go on to Mars with space vehicles, with habitation modules, with exploration, human-manned I shouldn't say manned, but crewed mobility, crewed rovers that we develop on the moon and then bring to Mars to explore the regions around any human settlement. So, I think the logical progression is to go from the moon to Mars. Going to the moon is going to cost us tens of billions of dollars. Going to Mars is going to cost us hundreds of billions of dollars, even if the initial exploration is done through the kind of techniques that Elon Musk has talked about with SpaceX. It's going to be a very, very expensive and very, very risky operation. And I think it's good to test that ability to test the equipment that's going to be needed to make ultimately a Mars mission, to do so with the Earth's moon.
Yeah, that's very interesting, Stephen. One last question I have to take because someone left on the audience from the live feed is what safety measures for safe eclipse to see, especially because it's not even seen in India. So, are there any safety mechanisms that needs to be followed to see eclipse?
Certainly not with the lunar eclipse. With the lunar eclipse, you're just looking at, if you've looked up at the moon, you've looked, during normal times when it's full or in a partial phase, you're seeing sunlight reflected from the lunar surface, and that's when the moon is the brightest. During an eclipse, when the Earth's shadow, passes over the moon, the intensity of that light decreases. And so, if you're safe when you're looking at a full moon, you're going to be safe looking at a lunar eclipse. The only time safety is really an issue in terms of eclipses is when it's a solar eclipse. And then certainly looking at the sun requires very special considerations in terms of how you observe a solar eclipse, but absolutely nothing to worry about with the lunar eclipse.
Thank you, sir. Thank you for your time, and thank you for sharing your inspiring stories about what motivated you in the first hand, and certainly brings back my memories where there used to be a weekly science program called Turning Point in late 80s, early 90s in India, where it was like a half an hour program every week. And there are a couple of other programs in radios, some science programs, and a couple of very easy to understand books for kids, like it's called What the Telescope Tells Us, where I used to learn a lot about the planets and the atmosphere with each of those planets and things like that. So why I'm saying this is, as we discussed, in India, a lot of people are literate but not educated, if I can put it in that way. So what we need is education, not increase in literacy, understanding science and scientific method, then trying to get over with equations and doing some math to score marks and get a good livelihood or a better life outside the country. So we continue doing this, putting efforts and collectively doing. Sarath Garu and many other people are behind this effort. Who are trying to educate people and bring the rationality into the common minds, people's minds. So it's very, very good to have you here. I know it's very late for you, and thank you again from each one of us for sharing, for spending your valuable time and sharing your experiences and opinions also. with our audience. If there is anything more, Sarath Garu, otherwise we can say a goodbye and good night for Stephen.
I would just want to say, I think Steve, Dr. Clifford, and Steve, as you would like to be addressed as, your passion for Mars, I think it's very inspirational, and I think your passion and love for science, planetary science, and I think I think it's highly inspiring, is what I felt during the course of our discussion, and it's past your midnight and your levels of energy and the spirit, and I think it's just showing. I would really, I thank you. We thank you, for your time and for your patience in answering all our questions, and I hope we would meet later again and then talk at length about many other things. You would be interested in sharing about science, about you, and about how we can increase enthusiasm towards science as general. And I think we can close with the Star Trek popular phrase, live long and prosper. I think that applies for everyone, for the humanity and everything. Yeah.
Thank you. It's been my pleasure to participate in the discussion tonight. I think you are doing a very valuable service in terms of promoting the understanding of science, and I think that is something that is extremely important, and it's important now, and certainly very important to the students and generations that come.
We're just keeping the fire burning.
Yes.
So thank you very much for joining us again.
Thank you.
This is this episode's Let's Talk Science. We'll be back with another interesting guest in the next episode. Thank you very much.